All right, welcome back. We are Game 3001. That's in the winter 2021 semester at George Brown, and it's week 5, part 2 of our broadcast. And what we're talking about is more pathfinding stuff, that's for sure. So welcome, everyone. And the pathfinding stuff we talked about earlier today was kind of all around how do I partition, my world? Should I use tiles or nodes? Of course, our lab is going to be mostly tiles. That's how we're doing it. And I talked about the positives and negatives of tiles. It can be quite computationally expensive to use tiles in a larger game. What are the goals of our lab today? Lab 4 goal is like this. We're going to add neighbor references for each tile today. That's what we're going to do. We're going to do this in a clockwise order, top, right, bottom, left. We're only going to, select neighbors in 4 directions. Right, that's what we're going to do. We're going to display the cost labels and status labels when the grid is displayed. We're going to snap a target to the grid. Right now, the target's kind of in the middle of the grid somewhere. We're going to also compute Euclidean distance to target for each of the tiles. And we're going to enable the target to move in IM GUI, and we're going to update the tile costs when we do that. So those are all the things that we're going to be doing. Lab 3B, yeah, Neil is where we're going to start. So like always, I go with my starter. There's a starter up on Blackboard for Lab 4, no problem. And I'm just going to click there to grab the starter. Just like you, I'm going to go there and grab the starter. So I'm going to download the code. Right, let's download a zip file. And as soon as this is ready, we're going to get moving and grooving. And you keep the last one. Yes, but then you're going to have to set up a brand new repository, Synen. So if you want to get your marks for your lab, you need to set up a brand new repository, which might be just easier to download and start over. Just saying. So it's up to you how you do it. It's totally up to you, but I highly recommend you start fresh, and this way you're good. All right, let's get moving on this. So I'm going to go to our desktop, and then we're going to go to GBC 3001, and I've already downloaded Lab 3B. Here it is. But let's suppose I had it in downloads, then I would just kind of drag and drop it in there like so. And then what I would do is I would unzip it. So please use 7-zip again to start fresh. Right, there it is. And let's get rid of that. We don't need the zip file anymore. We can rename this Lab 3B to Lab 4. If I can actually do something properly instead of, I hate when this does that. So I'm going to click and click again. And click one more time. Click a third time. Oh yeah, this doesn't want to do it for me today. I love it. Yeah, we'll just type it over. So we're going to do Lab 4B is what we're going to do. That's your lab, Lab 4B. And I'm going to start Lab 4B off by double-clicking on my template SLN file. Ethan says, should we download this? You're going to start with your starter. So that is up on Blackboard. Start with your starter, which is right here, and then go from there, please. All right, so here we are. So we've got our template. So hopefully you're starting off with me. Let's run this thing. I'm going to go back to x86. So I'm going to move to x86. And sometimes it takes an extra second for me to update my source files and a bunch of other things while this is going. Before we get started, as soon as the source files update, what I'm also going to do is I'm going to add my project to source control. Again, to do that, I'm going to right-click on Solution Explorer, and I'm going to create my Git repository locally. And then what I want to do is go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. And notice there's no changes, but I'm going to go to Home, Sync, right? And I'm going to publish to GitHub here. So that way you have my Lab 4 as I go. So this is going to be, we're going to publish it to Lab 4. not lab 4B, just lab 4. And then click publish. And of course, it's going to publish the wrong spot because I just put it on my account, not your funky account. But that's okay. We can fix it. I know. I love that. Let's fix that up again. So, by the way, if you ever run into this problem like I've done a bunch of times because I'm just like moving fast, you can always fix it. It's not a big deal. I'm going to fix my problem because I just created my problem, and I'll give you guys a chance to catch up here. So, and what I'm going to do is I'm just going to just fix me. Just give me 1 sec while I do that. So get remove origin. And let's try that again. So again, I'm going to publish to GitHub. It's going to tell me where to go. I'm going to go actually to the right place. Lab 4 is what it's going to be called. That'll be okay. And then I'll publish this link. Woohoo! That was a quick fix. There we go. All right. Now, what I want to do is up here on George Brown, you'll see that there's another link. And that's where you can compare your stuff with my stuff. Okay, lab 4B, lab 4. All right, so we ended off lab 3 last week. This week is lab 4, and there's only going to be one. I'm going to grab this link where I'm going to update my stuff at the end so you can compare yours to mine. And down in here, I'm going to add a new link. And this will be the lab 4 GitHub repo. And we're just going to put this up here. This is the starter, and this is the finished product, and we're going to be done. I want you guys to start at the starter and work with me. This is a great way of practicing. It'll make you stronger when it comes to your midterm tests. All right, let's get moving on this. So now that I've downloaded my project, I've got my Solution Explorer, I'm in x86 mode. I'm going to run and see what I got. So where last we left off, we didn't get a lot done. There's a lot of questions last week about your assignment 1. Your assignment 1 was also due, last Tuesday at midnight. So a lot of you are concentrating on that, and some of you got this done, some of you didn't. But what we want to do is, as soon as we've done everything, launch and see where we're at. Now it looks like it's pretty blank. Again, what we should have is this little target, but the problem with the target, if I set up the grid, is it's in the middle. So again, just like we said, what I want is for each of the tiles to have references first to every other tile, okay? And we got to consider how that works. And I kind of talked about this at the during our lecture. I said, like, okay, so if I want this little green area is kind of like the edge tiles, right? So for the green area, every time I kind of get a reference to each other tile, and we're only going to get the tiles around it. So for example, if I'm in this tile, I want kind of the tiles around this tile here as reference tiles. So these are the tiles I care about if I was looking at this tile. Each of these would be top, right, bottom, left. I'm going to wind in a clockwise order when it comes to how I set up my references. So 0, 1, 2, 3 is what I want, okay? We need to set up some kind of array inside of each tile that basically keeps track of all of the other references of the other tiles. So it can be seen as, each tile becomes a little bit heavier in terms of use, okay? So that's kind of something we want to do. So let's start. And one of the challenges or the questions I always get is, so where do I start? How do I start this off? Like, what do I do? Well, start thinking about the array has 4 positions, yeah. So let's start thinking about a couple of things here. I have my tile inside of game objects. Let's move it into its own filter. So I'm going to right click on my template. I'm going to add a new filter. And this filter is going to be called, we'll call it navigation, right? So this is kind of, or pathfinding, you can call it pathfinding. And what I want to move is I want to grab this tile class, the .cpp and the .h, and just move it into the navigation filter just so that it's easier for us to look at, right? So we can find it. We don't have to swim around and find everything else. Here's the .h, and then there's the .cpp. I'm just going to put the .cpp on the right of the .h, right? And what we have so far is that each tile draws itself, updates itself, and cleans itself. It's very basic. This doesn't do anything. It's actually pretty dumb. Right now, we need to make this tile a smart tile. And in order for us to do that, we have to start slow. There's lots of stuff we have to do. I'm going to start with the tile. And I think it's a great place to start, because we got to think about how we're going to represent everything. So what I want to do is I want to make a private area in my tile space, which is going to represent my each of my neighbors for a second, right? So again, it's going to be a tile pointer, right? It's going to be an array of tile pointers, not a vector. So we're going to call this m_neighbors. Again, you can call it whatever you want, neighbor tiles, whatever makes sense for you. I'm going to call mine neighbors, right? And I want to make it, you know, I want to have 4 of them. But for me to code this, what if tomorrow I wanted to change this, instead of 4, I wanted all 8 of them, right? Like, how do I do that? And also, how do I reference each one of them? 0, 1, 2, 3, 4, 0, 1, 2, 3. Maybe I'll forget what 1 means or 2 means a month from now. So an enumeration is a pretty good idea. So let's start with an enum. I'm probably going to call it something like neighbor tile, which is something that's really big, but who cares? So right click on the enumeration filter. I'm going to add in a new item. And when it comes up, you're going to see that it's pointing to the wrong place. Please browse into the source folder. Again, some people ran into this problem. They're like, I don't know why, but I can't find my game object class. Well, because you're looking in the wrong spot, right? So in my header, what I want to do is I want to change this to the name of my class, which is going to be neighbortile.h. And all this is organization. Okay, so I'm going to say something like, here's my guard, if not defined, neighbor tile. I know this is long. Then we're going to define neighbor tile and end if. And what this does, again, it's just an enumeration, right? So I'll let you guys catch up. So it's a friendly name that we're going to use for the numbers. That's what enumerations are, right? So just reminding you. Again, we can use an enum class. We're just going to use regular enum. So it's going to be called neighbor tile. And inside there, we're going to have the names of the tile positions. So top tile, right? We're going to wind in a clockwise order. So we're going to go to the right tile, the bottom tile, and the left tile. Some people like shortcuts, and that's fine. I'm also going to count the number of neighbor tiles. Okay, so I use this as a counter a lot of times. Like, for example, what if I wanted to put like top right tile and bottom right tile and bottom left tile and top left tile, if I wanted to get those extra tiles. So instead of 4, there's 8. Well, then this one would count how many tiles I'm looking at. Right now, it's only counting 4. And the reason why I want this is if I have an enumeration just like this, then I can use number of neighbor tiles in my tile class to start off. And I'll show you what I mean by that. So the neighbor tile.h is just a friendly way of looking at the positions in my index 0, 1, 2, 3, as opposed to, it's better this way because you'll remember what these mean a month from now, as opposed to 0, 1, 2, 3. You want to have a clue what 0, 1, 2, 3 means. All right, I know neighbor is kind of weird, eh? Neighbor. So I want to go into my tile, and instead of putting 4, I want to put in, you know, something like num of neighbor tiles, but I can't get to that because I haven't included it. Let's include it up here. So again, include, you know, we'll start typing neighbor tiles.h, and now I can type that in. I can say num of neighbor tiles, right? So what this is going to do is it's going to provide us a number that is going to be used for the array. And later on, if I wanted to add more, then I wouldn't have to remember how big this is, right? So it's going to be an array of 4 tiles, right, that it's going to keep track of. And that's kind of the first thing I'd like to do. So, you know, how many, kind of tiles I can put in here. Now I need some functions. I need some functions to set the neighbor tile, and I also want to return the neighbor tile or get the neighbor tile. I'm going to make these public, but you don't have to. So there's going to be two functions. So it's going to be get neighbor tile, which is going to be the tile reference. So get neighbor tile, whatever the neighbor tile is, and I want to give myself the position of the tile. So I'm going to use that neighbor tile enumeration for the position. So this is going to be returning the tile that I point to 0, 1, 2, 3, whatever it's going to be. It's going to be a nicer way of indexing which one it's going to be. I could also override and do all kinds of funky stuff with the constructor. Not going to do that right now. The next thing is, I'm going to set the tile. So it's going to be a void. So getters and setters, set neighbor tile. And my neighbor tile, again, there's two things I need. I need the neighbor tile position as well as a tile reference, right, that I'm going to set to. So those are the two things I need, a getter and the setter. So I want to be able to set the neighbor, and I want to be able to return what the neighbor is. If I want to look at a position later on, I want to see what the neighbor to the right is, or neighbor above or below. I'm able to get that information from each of the tiles. Let's set up this is the header of the tile. Let's now set up the definition. So generate implementation. So I want to do it up here where it says tile. Where it says generate definitions by declarations, it's going to automatically do it for me with ReSharper. There we are. So I got those two headers. And what I want to do is when I get the neighbor tile, right? So I want to get the neighbor tile. It's what I need to do when I get it is I want to return the position. So I want to return the m_neighbors, and then I want to pass in the position that I'm returning. All right, so that is getting the position. Setting the position is a little bit more difficult, but not much. It's going to just be m_neighbors, and then whatever the position is equal to tile. Okay, that's kind of what it's going to be. And what I can do is I'm going to accept some ReSharper C++ recommendations where I can make these constant. Okay, so that is your getter and your setter. Without these two things, there is no real easy way for me to set and get tile information. And the first thing I want to do is create a relationship between each tile with every other tile. I want to be able to know what tiles to the right of me, above me, and so on. And the cost of each tile, where if I want to add up the total cost, I can just, literally go from one tile to the next to figure this out. Speaking of tile cost, that's one thing we haven't dealt with. So just as an additional thing, again, so we're now able to get and set neighbor information. But what I also like to do is set up our cost. So I'm going to put this before everything. I'm going to say float. We're going to say m_cost, cost of the tile. By default, we're going to say the cost is the default tile cost, which would be 0 for now at the beginning. So what I'm going to do is in the constructor, I'm just going to zero it out. I don't have to, but you know what? Why not? I'm going to go up here where it says tile and go m_cost is going to be equal to 0. So it's going to zero that out. By the way, if you get some really weird errors like that, like I just gave you, and of course it's a floating point cost, so I might as well put in the floating point cost so it's right. This is a float. And I want to be able to set the tile cost and get the tile cost because I need to set up getters and setters again. So let's do that again. So we'll say that we want to float get tile cost. If I want to read it, there we go. I want to get the tile cost and I want to set the tile cost, which is a void set tile cost, which we're going to say that it's a floating point cost that we want to set. So I'm just setting these up so that we have a mechanism for setting and getting and setting the tile cost that's outside of this class. Right? Again, what I want to go is to go up here and look at generate definitions by declarations. And what we're going to see is these things: set tile costs, get tile costs. Pretty simple, right? And again, just like before, when it comes to setting and getting the tile costs, there's going to be some additional things with the setter. Like right now, all we need to do is say something like m_cost is equal to cost. We're going to add to this because later on, what I want to do is I also want to display the cost in a label. So as a note, I'm going to say, so to do, display cost in label. We need to do that. That's a to-do item. I know that that's going to happen later on. But when I return the cost, it's just that simple, m_cost. Remember that the getters and setters that we have here are, they're more than just data access. They're there so we can do other things in the method. Neil says, do we have to use getters and setters in the constructor? No, but I mean, it's okay if we do. Like, for example, if I wanted to set the cost here to 0, I could. So if you wanted to go here and instead of setting the value, can I use a getter and setter here? I could definitely do that. I don't think it's wrong to do it. So I could say set tile cost to 0. That is totally fine to do. There's nothing wrong with doing that, which we kind of have done already, right? Set width and set height, right? So that is something we need to do. Get tile costs and set tile costs. We want to be able to do that and display in a label later on. We don't have labels, and we're going to add them in. But first, what I want to do is get that reference happening. I want to get the reference from one tile to the other tile. And so this is our first step. Our first step is let's add the ability, or let's enable a mechanism of getting and setting tiles or neighbor tiles. Okay, that's one thing we want to do. Now, in the playscene.cpp, that's our next step. We're going to go to our playscene.cpp. So in the playscene.h, actually, we have the following structures right now. We have a build grid method. We have a set grid enabled method where we can hide and set the grid. We have a vector that we're using called grid. We could possibly make this later on into something more powerful like a class, but for now it's not necessary. And so this is our build grid and whatever. What I want is the ability for me to, and we also have a target. We have a target object. Okay, so this is all stuff that we have right now. Okay, in our playscene.cpp, right, and we're going to start inside the start method. So if I go to definition for my start method, all right, there it is. Then what we have right now is a place scene and a target as an example, and we have build grid. But build grid, right, it does right now, if you scroll down to build grid, doesn't do much. It just sets up a grid for the first time. Okay. And what we need to do alongside with building the grid, right? Alongside building the grid, we also have to have a mechanism to create for each tile. For each tile, what I want to do is I want to set up its neighbors, right? So, and now there's a couple ways to do that, but I'm probably going to need another loop. I can't do it here. And you're going to ask me, well, wait, what do I need a second loop? Well, here, what we're doing in this set of double loops is I'm building out the grid, right? So I'm adding kind of add tiles to the grid. So this is what I'm doing with this block right here, right? I can't look to the right of where I am. I can't, like, as I'm building the grid, remember what I'm doing. I'm starting here and I'm going across the grid like this. That's what I'm doing, right? So I can't say, well, what is my neighbor tile from here if this neighbor tile has never been created? Can't do that, right? I mean, you're going to get a reference error. So first, I need to build the basic grid first. I need to do this first. Once I have this, then I can remap. I can start going back and do a second pass and remap every tile in the grid with every other tile. Okay, I need to do that first. So I need another little double for loop. And I'm just going to copy these two spots right there and just go down. Be very careful when you start this off. I'm just going to add in a couple of curly braces, right, to kind of create my structure. All I'm doing is borrowing from the first part of this to get going. So does everyone understand that, why I need to do that? Is it okay to do m underscore cost is equal to 0 on the constructor? Yes, you could. But like I said, Neil, if you directly access the data member, maybe you want to be able to go through the, again, it really depends on what you want to accomplish in the constructor. That is totally okay to do because you're initializing, right? But sometimes what you want to do is not just initialize, but also do other things, right? So that's why you may want to do both. All right, so here's, again, a couple of loops. And again, I add tiles to the grid. And for this grouping, I'm going to create references for each tile, to every other tile, to its neighbors, let's say. So its neighbors. That's important. So I'm kind of going to look at each tile, and I'm going to say, as an example, going back to the grid, well, what are the neighbors? I don't have a neighbor here. This is null, or null pointer. This is null pointer because I'm an edge tile in this case, right? But this one should have a value, and this one should have a value. So I should have these two values, but these ones should be null pointer. So there's a case here that we can look at, right? The top left corner has this case that I talked about during lecture, where for every column that starts with 0, any tile with a column number of 0, I want to set its left neighbor to null pointer, right? For every column, every tile that starts with a column of 0. For every tile that starts with a row of 0, I want to set its top neighbor to null pointer. For every tile that I want to start that has a maximum value of the row value, then I want to start its right neighbor to null pointer. And for every tile that has a row with the maximum row value, right, then I want to start all of its bottom neighbors to 0. So that's what I need to do. And I need a bit of a convenience function to help me out. And the convenience function that I want to set up is a way, and you're going to see that I set up little convenience functions here and there to help me do some calculations, little things that I don't have to do over and over again. One of them is I want to be able to pass in a reference because I want to be able to, I don't have a two-dimensional grid, I have a single-dimensional vector. So I want to be able to index the vector by column and row format. I want to be able to, kind of pass in a column and row into a function, and it's going to return to me the tile that I'm looking at, any tile that's here. So if I say something like 9, column 9, row 5, it should give me this tile right here. That's what I want. Okay, column 9, row 5. By column, row. Column would be X, row is Y. So I need a convenience function before we start going. And I'm going to call this get tile. So again, it's going to be back in placing.h. I'm going to make a new convenience function called get tile. I'll put the convenience functions under here. So convenience functions. I call them convenience functions because they help us to do stuff, as opposed to, you can also make macros. I'm just going to use it this way. So it's going to return a tile, this convenience function I'm thinking about. I'm going to call it get tile. You can also say get tile from grid if you really want to, but that's what it is. Get grid tile, lots of ways, but I just want to call it get tile. And it's going to be a private function because it's not going to leave the class. I'm going to pass in a column and a row coordinate, right? And I'm going to get back a tile from the grid. So it could be called get tile from grid if you really want to. It's just a little shorter this way. And I want to generate my implementation, which is right here. And that's not what I want it to do. I want to generate my implementation, kind of thing, not inline. I don't want to generate my implementation inline, just this way. It shouldn't be inline. It should be generate implementation, or, just like we did before, where I kind of generated my definitions by declarations. I don't want to do it this way. This is inline. This is bad, right? In my .h. I want to put it in my .cpp. Sometimes it does that. I'm not really a fan of how that works, as an example. It's just a way of doing it. I mean, I could type it myself too, right? But it's just, I prefer, it reduces finger typing errors, as an example, when I just generate my implementation like that. Sometimes you just have to save the files and that does it for you. All right, so now that once I have it, then I want to think about how this is going to work. I'm going to say that this is going to return, hear me out now, m_p_grid, right? I'm going to pass in a couple of things. I want to pass in my row, and I want to multiply it by my config column number, right? And then I want to add in the column. That's what I want to do. And let me explain how this is going to work. So let's put some brackets around here so you can really clearly see it, where I do my brackets first. Again, it doesn't matter. It'll run the exact same way. But what I'm saying is, okay, take my row, my current row, whatever I pass into it, and let's just make it so that it satisfies our resharper, recommendations. I'm going to take my current row, multiply it by the column number, right? So column number, again, if I look at the grid, if my current row is 0, I multiply it by the column number. So then it's 0. Okay, and then I add the column. If it's the first column, it's 0. Okay, what about if I said I pass in a column that is column 10, row 3? Okay, what number will that generate for me if I do that? So if I pass in row 3, that's what we care about first. So row 3 is 3 times my column number, which is 20, so that's 60, plus 10, so that's 70. Does that compute? That would be 70 in my array or my vector. How does that work? Well, let's start counting from here. If I said 1, this would be 0, 1, 2, and so on. 1, 2, and on. If I count that like this, right? So if I do this, so this would be 19. We know that. This would be 20, right? This is 21. This is 22, right? Hear me out for a second. I'm doing this with you just as an exercise so you see what happens. This is 39, right? And this is 40, right? And this is 41, and this is 42. So you can see the mapping, how this works, right? And this will be, 59. This will be 60. Remember, we want to go to 10, right? Row 3, column 10, right? Let's see how that works. So then 61, 62, and then what happens is we're going to go all the way to column 10, which should be 70. So that's the 70th position in the grid. Does that make sense to you? Right? So if I go 10, 3, it's going to translate into a number of 70 from the grid position, right? So I don't have to think about that number or how to generate that number later on. I need a convenience function to help me do that. And that's what this is going to do. This m_getTal is going to translate column and row into some value that's going to access the grid. Make sense? First step. Okay, now that I have the convenience function, right, what I want to do is up here in my row column, right, where I actually do things with the setting references to each part of the grid, I want to think about getting a reference to my, wouldn't it be 40, not 70, Ethan? So no, it's not times 10, right? It's times the column number, right? Remember the column number? It's by column number. So I multiply by column number. So I have a total, each row has 19 or 0 to 19 columns, right? So it'd be times 19. So that's 20, right? 20 spaces, right? And then add the column afterwards, right? That's why I'm telling you it's confusing. Unless you do it now, you can mess up. And then once we mess up, it's hard to, to troubleshoot, right? Because we're trying to do a lot of things at once here. Next, what I recommend in the double for loop is a temporary tile variable. You don't need it, but I like to use a temporary tile. I'm just going to call it tile. And what I want to do is I want to get whatever the current tile is by passing in row column. So whatever the row column is, that's going to be the tile that I'm pointing to. So I don't have to do this every single time, right? Okay, next, what I want to do is I want to say this. I want to start testing. So remember I talked about all those edge cases. Here's one edge case. If my row is equal to 0, that is an edge case, right? Then do something, right? And then else, do something else. Okay, so these are pretty simple cases, right? where I want to set the tile to some value. And in my row, when my row is equal to 0, what I really want to do is I want to say something like this: tile, I want to set neighbor tile, and it's going to be, remember, I start thinking about the row. When my row is 0, when my row is 0, and I'm starting to wind, from a clockwise direction, starting with my top tile. This would be top tile, right? And then I say that if my row is 0, then my top tiles are null pointer, right? Null pointer. Why? Because if you think about it, that is me being here at the top tile. I'm just going to erase all this because we don't need it. That was just for my demo. So if you hear right here, then my top tile, for any time that my row is 0, all these top tiles are null pointer. They don't exist because I'm at the edge. I'm at the edge of my map. So there's no top tiles. There's no reference to them. Okay. So that is what this top tile is. Top tile is 0. So otherwise, what is my top tile? We're going to find that out. Let's keep going with my edge cases. The next edge case is, what about if my my column, right, is equal to 0? What does that mean? If my column is equal to 0, then it means my left tile, right, is null pointer, right? So let's grab this line and put it here. This is my other case. This is left tile. So my left tile is null pointer when my columns are 0. Else, when my column is not 0, then what is it, right? We can start filling in the blanks. And again, I'm making a long form. There's shorter ways to do this, but I want to just start your thinking process, right? So again, when I'm looking at this column here, that means all my left tiles are null pointer, right? All my left tiles, because there is no left tile. It's off screen, right? All right, what about the other two edge cases? The one where my, so it's top right. Let's go to top, let's go to the right here. How about if my column, right? My column is, is equal to the config column number. Config column number. Column number is like 20, right? That's how many columns I have, 20 columns. But I can't go to my column. It's never going to be my column number because I've got a for loop that takes me up to my column number, but never at my column number. So I got to put in column number -1. So if my column number is at the edge, then what does this mean? Well, this means that, let me put the else in there so you can see the difference. I'm going to take one of these. That means that my right tile, right, is null pointer. What does this mean? Why? But if I go back to this and I demonstrate, that means all of this. When my column is at the edge, my right neighbor is 0. That's what it means. There's nothing there, right? Finally, my last case is if my row, right? So, again, top right, and I should probably put it in order instead of putting it right here. Bottom is this one. Bottom is here. So if I say if my row is equal to my, just same as before, config, and then it is row number -1. So again, I can't go to the total row number. The row number is maximum of 15. 15 minus 1 would be 14. Why? Because up here I check up to but not including 15. That's what that number is, right? So I want to say, well, if it's 14, then I know that my bottom neighbors are all 0. So that's what I'm doing. So again, I grab this next one. It doesn't matter which one you grab. Just going to grab a piece of thing there so I don't have to type it. And this is the bottom tile, right? And then I have an else statement. What if it's not? Okay. Again, this is only one way of doing it. You can optimize for sure, and you can try and make it a ternary operator where we do something all at once based on the thing that I'm getting. I could do it in one, but we're not going to do that. Okay, so make it easy so you can see it and understand what's happening here. So this is top, top row. This is right column, right? And this is bottom row of tiles. And this is left column, leftmost. So this is leftmost column, right? Leftmost column, rightmost column, topmost column, and bottommost column. All right. If you really want to go there and be exact. Okay. So now what if it's not the topmost column? Well, if it's not the topmost column and if it's some other row, then what I want to do is I want to set up the tile neighbor. So let's do that now. So tile, and I want to set neighbor tile, and I want to be the top tile again. So what's my top tile if it's not the top row? Anything else other than the top row and not the bottom row? Well, then I want to say that m underscore get tile, and I want to pass in my column information, but my row is -1. Whoa, what does this mean? Well, because it's any other tile other than my top row, right? So that means that for my top tile, any other row other than this one, then if I'm here, then the top neighbor is this one. If I'm here, the top neighbor is this one. If I'm here, the top neighbor is this one. That's what I'm saying, right? So that's why this is valid. Okay. All right, what about the other one, the other case here? So let's just grab this and put that in here. And what's this going to look like? So I'm sure you can guess what it's going to be. This one is if I'm figuring out my right tile. So the neighbor, my right tile neighbor, the one to the right, if it's not the edge, then the neighbor to the right is, my row is the same, so same row, but my column, right, is when I'm accessing is one to the right. So that means that if I go back to this, that means anything other than this scenario, right? If I'm here, then my right neighbor is here. If I'm here, my right neighbor is here. If I'm here, my right neighbor is here. Okay, that's what I'm doing here. Okay, let's keep going. And I'm just going to grab, this one, just to make it easy. So now it's bottom tile time. Bottom tile. So when my bottom tile, if it's not the bottom of the bottommost row, if it's not the bottommost row, then what I want to say is my column is whatever it is, but my row is +1. That means it's like the next row down, right? That's what it means. Okay, and again, just to finish off, I'm just going to grab this one. And we're going to fix up the left row, the left tile. If it's not the leftmost column, then any column that is to the left of where my current position is, and the same row. So that completes the mapping kind of activity. How do I prove it? How do I prove that this is the mapping activity? And I'm just going to show you this right now and put it up on GitHub in a second so you can see it. First of all, do you understand? Does everyone understand what I'm talking about? Check mark if you get it, X if you're lost, right? Because I think, all I'm trying to do is make references. I'm getting references to each of the other tiles around the current tile that I'm looking at. If it's an edge case, if I'm on the edge of my my borders, if I will, then I can't get something that's off screen. It's going to be null pointer. Okay, a couple of people are saying they get it. Other people are not answering. Neil gets it, and I see that Dat gets it. How about anyone else? Anyone else get it? Jacob? It can be challenging, right? When you first look at this thing, it's challenging. Okay, how do I prove it now? Thank you for that feedback. How do I prove it? Well, let's run this thing, and what I want to do is at the bottom, right? At the bottom, I want to print out my my grid, size, let's say. So one way of doing some troubleshooting is doing a cout and then saying something like m_p grid, and I want to put the size, I want to display the size of my grid, which should be 300. And I'm going to put a breakpoint. This is a great way of doing it. I want to put a breakpoint there. And what it'll allow me to do is when I'm finished, mapping my references, then I can hover over my grid and in real time, it'll show me what's inside of it. So using breakpoints is a great way of doing that. It's the gutter here that allows me to take a look and inspect items in real time. All right, let's see if I can do this and what happens. So let's run it. Hopefully we're going to get no errors. Maybe I'll get an error, don't know, right? It's doing its little dance. So it's going to take a second to do this. And if we get this, I'll put this up on GitHub. All right, cool. So it stopped. This is perfect. So what's happening is it says my size is 300, right? And now what I can do in real time is if I hover over the grid, m_p grid, and if I open it up, there's a little arrow here that I can open it up. I can actually look inside of it, and I can start looking at each tile in the grid. Let's look at tile 0. Tile 0 is my topmost tile, right? And if I look at the neighbors, you can see that the neighbors should look something like this. Neighbor 0, top, is null, right? Because it's the top left tile. The top and the left is 0. So top, right, bottom, left. So top and the left are 0, but the other ones have some kind of values. And this is good. Now I can actually drill into it. How about the one on the right? If I drill into it, the one on the right also has some neighbors. It has the one on the right of this tile. The top is 0, but the rest, right, bottom, and left, are all filled up with references. This is how you look at it. Null means no null pointer, which is a way of inspecting the grid. So everything has worked out exactly perfectly like I wanted. Okay, are you with me? So check marks if you understand what I just did there. So let's stop this. And X is if you don't understand. I got one check mark, and even if you can't follow along because I went too fast or whatever, I'm going to put this up on GitHub in a second so you can kind of match my code with your code. Can you show the debugging once more? Sure. So again, I just use a simple output statement just so that there's a place to stop. I can't just debug anywhere I want. I got to stop it on a statement, like a command like this, right? I use this little red mark on the left is my debug point, right? And I can add any number of them that I want in the gutter, right? But it has to be significant. It has to be in a space that makes sense. So I want to make some kind of command. Like this is a useless command. I'm printing out the grid size, but it allows me to actually inspect the grid at this location because that's what I'm looking at, right? So that's the first thing I do. I put this in there. And then what I do is I run it. Because we're in debug mode, this debug point will come off. If I'm in release mode, no, it won't work. It won't work. It won't be accurate. So it starts to run, and then when it gets to, after it starts building the grid and mapping it, all the neighbors, it comes to this point. Before it prints out the grid size, I have access in real time to the grid. And if I hover over it with my mouse, you see that there's a little, thing that's a collapsible area for my entire grid. Now there's 300 spaces on it. And what I can do with the grid is actually I can pin it. Notice this little pin. If I click pin, you can see the grid, and actually I can look at it. I can move it around, this little pin. You can unpin it too if you want. So there's the grid. I can look at it, and I can pin the grid if I want to. So I can pin it back up. There's the pin. And I can open it up, and then I can pin another location. Let's say, for example, I want to pin the next location inside of it. I can do that. I can open this up, open up 0, and then I can pin this location, right? And I can look at the neighbors, right, as an example, and I can kind of inspect each of the neighbors inside of here. And you can see that each of the neighbors, it's a neighbor array. So the 0th location, the first location, the second location, the third location, and it shows us, we can inspect what's inside of there. Hopefully that gives you some examples of what to do. You can unpin this now, okay, and close this down. So again, you can do this anytime with any object, even other things that are outside of this area. If I want to look, for example, at the grid here, I can do the same thing. Or I can look at what the tile enabled state is, right? What does this return? If there was something that made sense. Notice that there's nothing. I've never kind of gone in here, so I can't look here and see what the values are. So this is one way of doing it. The other thing that you can do is you can look at some other windows down here. On the bottom, I have a locals window, and I have a autos window. And what the autos window does, I can look at the grid in here as well. So you can actually, the grid is locked in here. So this is something you can do too. This is another really valuable debugging tool that you can use where you can actually look at the grid inside the autos window. And again, you can see what the values are down here. This is a great way of looking at it because it'll look at anything that is available to us that's being used. So this is a really valuable. Again, here's the output. That was my default. And on the right, you also have the call stack. And the call stack is super important because what it does, it tells you the order of every call that I've made so far in my game. So notice it starts off, and here's my Windows API running. I get the command line. I start running my SDL main, right? And then I initialize inside of my game. I initialize my window. I start my start function. My start function calls my change scene. So I start my play scene. My play scene starts the start function, and my start function calls build grid. And that's the order of calls, or method calls, if you will, all the way to where I have my debug point, which is on line 183 inside of my build grid function, right here. Okay, that's what the call stack's all about. Sometimes I use both to debug, to say, okay, what happened? Where did it break my code? Right, so I use both the call stack, as well as I can inspect different items in real time to see if I'm getting the right values. If I get some garbage values in here, like if, for example, if the cost was a garbage value, or if my neighbors were garbage values, null pointers, or something else, then I would know there's a problem. Okay, so let's stop debugging. I know that I'm good. I can remove the debug point, and this is a great place to put it up on GitHub. So Team Explorer, I'm going to push this on GitHub now. So again, I'm going to go to Home, Changes, and from there, I'm going to see all these changes. I'm going to say, created or made neighbor references. Made neighbor references for each tile. You can put in some other kind of comment that's similar. Commit all, home, and then sync, and then push. Please check my code and compare my code to your code if you've got any issues, and it'll be pushed up and about, it's up now. There we go. All right, so that is the first step. The first step is making references, and what we've done now is I now know each tile knows about the other tiles. Okay, we need to know those things when it comes to adding up total costs. My total costs, I want to do a cost so far if I'm doing a route, right? If I'm doing a different kinds of paths, I want to have the cost so far, right? Okay, step 2, I want to display everything. Again, I'm just going to go back into my goals for today. So I've done this already. We did it in a winding order. The next part is I want to display the cost of labels and the cost labels and status labels when the grid is displayed. This is going to be a little bit more tricky because of the way we have everything done. In order for me to do this, I need to go again back into my Visual Studio Code. I'm going to go into my tile.h here, and you can see that I've got my get tile costs and set tile costs. What I need now is a couple of labels. I need a cost label and a status label. Okay, this is inside my tile.h. All right, so again, let's put them in here. I'm going to put them up here. Again, you can put them underneath your costs or before your costs. It doesn't really matter, right? It's just, you're just declaring where they are. We're going to organize this later anyway. So here's a label, and my label is going to be m_cost label, right? And it asked me to install label.h. Yes, I like that. Thank you very much for that. I also want to put in another label that I want to display called status label. So I got a cost label and a status label. Cost label and status label. Cool. All right. Well, there's going to be some challenges, right, that we're going to talk about. I need to instantiate the cost label and my status label. And there's a couple places I can do this. I can do it inside of my constructor. So my constructor, when I set things up, I can set up my cost label and everything else. But here's the challenge. How do I draw it? I can't draw it here, right? This draws each of the objects. My label is actually a game object. And I want it to connect, again, to the same scene. That's what I want it to do. So I need to add child, so it's part of the display list. I don't want to make it so it's running away on its own in a draw function. That doesn't make any sense. I want to take advantage of the display list that I have in my scene. I have a mechanism for this already laid out for you, and it is my parents. So every object in the scene, if I go to scenes, or if I go to core, just to show you this, and if I go to the scene class, right? The scene class has a bunch of stuff. It has add child, remove child. It allows me to do these things, add child and remove child. This is nice. but I also want to add to or get my parent. And the parent, if I look there, is, let's take a look at the display.h class, display object.h. It has get parent and set parent. And when I add child, this is funny, but if I go to my scene and look at add child, go to definition, this is my scene superclass, right? Then inside my scene superclass, what I'm actually doing is I'm setting the parent scene to whatever this is. So whatever this scene is, I'm setting the parent scene for that particular child to this. I'm already doing it for you. So whenever I add a child to the scene, I also have the parent scene mapped. So in other words, if I add a tile to my scene, I know what the parent scene is, and I can add in the labels that belong to the tile to the scene too. However, we have an order issue, right? When I'm instantiating my tile, so I'm instantiating each tiles during the build process, right? So I'm here in my play scene, and I'm in the build process, which is right here. I build up my tiles, and what am I doing? I instantiate my tile. Well, until I actually have a tile that's been added to the scene, I don't have references to my parent, right? I have to add child my tile. So I can't do it in the constructor. I can't add the labels in the constructor. I have to have another mechanism, which means I need some kind of other function to add my labels, right? Or initialize my labels. I'm going to make an add labels function that's part of my tile class. So again, going back to my tile class, it's going to be a public function. It's going to return void, and I'm going to add labels. Okay, that's what it's going to be, add labels. On that, I can add them, but then they're like loosey-goosey floating around. I need to enable them and disable them, right? Because, I'm going to be able to turn them on and off, and I can't, just because I enable my tile or disable my tile, doesn't mean my labels get enabled and disabled, right? So I need to have another method that does that. So set labels, let's say we'll call it labels enabled, and we'll put in a Boolean state for that for now. Again, these are things we can optimize later. Add tiles, add labels, and set labels enabled. Let's make those two methods. Again, I'm going to go here and say generate definitions by declarations. So I've got those two methods now in my tile class. Add labels and set labels enabled. You're going to be seeing why in a second. So when I add my labels, let's add one at a time. So my label that I want first is my cost label. M_cost label, right, is equal to a new label. And let's size it. Let's make it like 99.9. That's what I want the label to look like. I want one, level of precision, one significant digit, right, that I'm going to show. And let's make it print out as a consolus font, something that's pretty straightforward. And let's say with the size of like 12 points on the screen relative to what I'm saying. Cool, I like it. Okay, cool. And what I want is when I add my labels, I want to also set the transform. What's my transform? This is not tied into I don't have parenting right now for my framework. It would be nice if every game object could have children, but it doesn't. Only the scenes can have children right now. And I think in future iterations of this framework, maybe we can add that in. We can make it so that every game object could have its own children. For now, it's not like that. So what I need to do is I'm going to say M_cost label dot get transform. It's a little bit tricky. Get transform. I want to set the position, which is going to equal to the transform position, right, of my tile, right? But my problem is if I just did this, right? So I mean, let's just do this first and see what the problem is. So here's my position of my tile. So the position of my label is the position of my tile. Let's do that first. And then what I want to say is, let's get my parent, right? My parent's reference. And I want to add child, the label to my parent. So cost label. And what I also want to do is set up the cost label so that it is for now, it's going to be always enabled. Okay, I'm not going to set this set labels enabled thing working yet. I just want to add labels in here. All right, so that's the first little iteration of my code. I want to add this label. It's going to be added in the middle of my tile. And where is that? How does this look? Okay, so that is the first step. But what I want to do is when I'm building my tile, my grid, let's go back to my placing.cpp. I build my grid here, right? So what I want to do is I got to set up my position for my labels. So I'm going to say that, hey, you know what? Let's add my labels here. So I'm going to say tile, right? And I want to add labels, right? Because this is going to add my labels to each of my tiles. I'm going to enable all my labels here. Okay, adding labels, and I can enable and disable them. So that's what this does. I need to put this line in here, and this can't be here unless you've already set up the add labels method inside of your tile. I'm glad it's making sense, Ethan. If I play this now, I'm going to get just the numbers and no tiles because my tiles are disabled by default, while my labels are not. Right? So you're going to see the numbers floating in space like this. But notice that they're offset. Why? Because they're pointing at the location of my tile physically in the world space. My tile physically in the world space is top left centered. It's not centered in the middle, if you remember. I'm not doing it that way for my tiles. My tiles have a top left anchor, right? And that means I have to create an offset for each of my tiles. An example would be if I show my tile, my grid now, you can see that each of my positions, the label appears at the top left corner. I need to move it over to the right and down by half my tile size. So that's the offset, and it's a pain in the ass. I don't like that. We need to fix that sometime. All right, so what does this mean? Well, let's go back to add labels. All right, so I'm going to go back to my add labels in my tile.cpp. Yep, give me a sec, Neil. I'm going to do this part, and then we'll take a 5-minute break. I'm going to go back to this place right here, and what I want to do in my position, right, is I want to add my offset, right? So my position is going to be, here's my offset, and you could break this down if you really want to. Like, for example, you could say something like offset, because we're going to use the offset more than once. So you can say something like auto offset, auto meaning it'll take whatever it's going to need. I'm going to say that it's a GLM vec2, right? And the GLM vec2 is going to be my config tile size, right, times 0.5 f, and my config tile size times 0.5 f. That is my offset, right? Does that make sense to you? So this is the offset that I need to add into my position because it's my anchor is in the top left corner, and I want to swim to the right, and then I want to swim down. That's what I'm doing with my position. So when I say swim, I mean actually move where the labels are going to show up. So I'm going to say plus offset. Okay, that's what I want to do. Plus my offset. We're going to do this offset again later. That's why I put it here. And then if I run it, and I will take a short break after this. If I run it, then you'll see that the tiles now the label should be in the correct spots if I show the grid. Right, it's exactly in the middle of my grid, and it's just showing the maximum size, 99.9. I'm never going to have a number like 99.9, chances are, to display in my grid, right? And I want to be able to click on my labels and remove my labels like this, and we'll do that after the break. So let's stop. And we'll add in, we'll take a short break. When we come back, we'll finish add labels, and I'll start up the YouTube link again, and we'll continue with displaying my labels on the screen. All right, so let's take a short break, and when we come back, we'll come back, let's say, in 5 minutes, and we'll start off with the next one.